All right, everyone. We are going over systems of equations tonight. And I've got a couple different examples of each. So we'll go over all of those as best we can, go into a little bit of detail, and we'll kind of go from there. The first set that we're going through is going to be solving systems by graphing. And hopefully, either if you're watching this now or by the time you're watching it, you'll have gone over graphing already because honestly, if you don't know graphing, these first two really just aren't possible. Okay. In reality, all you're doing for both of these is you're just graphing each equation on the same graph and you're seeing where they cross, right? What a graph does is it graphs all the different possible solutions that you have. So the place where they cross is the one place where they have a solution in common, which is exactly what you're searching for. Okay. How you graph each of these individually is up to you. Okay. So that first one in green, I'm just going to do by making a quick table. Okay. With X and Y values that make the equation true. So 6, 0, 4, 1, and 2, 2 all seem to work when I plug them in for X and Y. Okay. If you want more details on like how I came up with those numbers, I'd suggest making sure you watch the graphing review first. Okay. 6, 0 is right here. 4, 1 is right here. And 2, 2 is right here. Okay. Initially, I'll just connect those with a line. I'm not going to put arrows on the end just yet because if for some reason my graph doesn't cross at one of those 3 points, I'm going to need to keep that graph going in order to figure out where they cross. Okay. So I need to see first, do I need to make my line bigger or not? Okay. I'm going to do the exact same thing for the blue graph. I'm going to make a set of X and Y values. I've got -4 and 0 works, right? Those would multiply together to be -8. I've got -3 and 2. That works, right? That make -6 minus 2, which is -8. And -2 and 4 also works. Okay, so I'm going to plot those. -4, 0 is right here. -3, 2 is right here and -2, 4 is right here. Okay, so what you'll notice is initially these do not cross. Okay, ooh, I'm not going to add that arrow onto the end there. Sorry about that. Okay, there we go. So what I need to do now is I don't need to actually find any more points in my table. I just need to continue the slope going that I've already discovered in both of these. So I'm going to continue my green one going. Looks like I'm going up 1 and left 2 to create new points. So I'm going to go up 1 and left 2. And when I go up 1 and left 2 again, I find that right there is where they cross. Okay, they cross at -2, 4. So my answer is x equals -2, y equals 4. You could also write that answer as an ordered pair of -2, comma 4. Both of those would work great. Okay. Second one should be even more straightforward because both of these are in slope-intercept form. Okay, so I just suggest continue those slopes as much as you can, really, until you figure out where they cross. Okay, so for the first one, the one I'm going to do in green, my y-intercept is -2, and my slope is 3, which I'm going to change to 3 over 1. So I'm going to go up 3 over 1, and I'm going to do that really until I fill the graph. Okay, I'm going to go back to my beginning point now, and I'm going to do the exact opposite of that so I can get some points going the other way. I'm going to go down 3 and left 1. Okay, and that's enough to basically fill my graph. So at this point, I'll just connect them with a line, and here's hoping it crosses at one of those fine points. Okay, for my one in blue, I'm going to start at +7. That's my y-intercept. And since my slope is negative, I'm going to go down 3 and right 2. Oh, look, they crossed already. So I seem to find that pretty quickly. That is at x equals 2, y equals 4, or it's at the ordered pair 2, 4. So honestly, solving systems of equations by graphing is really just a matter of putting two graphs on the exact same graph and seeing where they cross. Okay. So if you know graphing, you can solve a system with graphing pretty easily. Moving on to the next side. Um, we're going to take a look at substitution and elimination. These are your algebraic methods of solving. Okay. um, for substitution, your goal is to get one of your equations to have either a y equals all by itself or an x equals all by itself. It doesn't really matter which one you get. Okay. So looking at that first one in number 3, what you're basically gonna, well, I'm sorry, what you already have one that works. Sorry, I kind of stuttered a little bit there. You already have one that's all by itself. You have that second equation that already says y equals this. Once you have that, the key is you have to use your other equation now. So I'm gonna rewrite this equation so it makes it a little bit obvious what I'm doing. Negative x minus 7y equals negative 22. And then what you're gonna do, don't mind me, I'm just gonna do a little erasing here. I'm gonna try that one more time. Leave a little space in there. Okay, and then what you're gonna do, this is called the substitution piece. So what you're gonna do is you are going to get rid of the y. Okay, and that's because I have y equals in the other equation. So I'm going to get rid of the y. And in its place, I'm going to put 4x minus 1. There we go. So what I'm doing is I'm saying my second equation says, okay, my second equation says y equals 4x minus 1. Okay, so I'm going to take out the y in the first equation and plop in 4x minus 1. Okay, I'm going to plop in what it's equal to. At this point, now you've got one equation and you got one variable. Okay, so you're just going to really do the math here. You're going to distribute. So I got negative 28x plus 7. And I'm going to combine my like terms. Those combine to negative 29x. I'm going to subtract 7. I got negative 29x equals negative 29. And I think we can probably figure it out from there. Divide by negative 29. I got x equals 1. Once you have what x is equal to, then you've got to go back and figure out what y is equal to. You can use any of your first two equations. I'm going to use a different color because I'm hoping it'll help out. Kind of ran myself out of room here. And you can plug that x value into either your top equation or your bottom one. I'd go with the bottom one because the y, which you don't know, is already by itself. So I plug in 1 for x, make it 4 times 1 instead of 4x. Do the math and you get y equals 3. X equals 1, y equals 3. Okay, great. Moving along to the second one. So the difference really between the first one and the second one, and this is why I didn't bother. I put both of these on here, excuse me. The reason I put both these on here is really simple. This one, the second one, does not have an x or y by itself. Okay, I've got 3x plus 8 or y, and I've got an x minus 4y. Okay, so what I need to do is get one of those variables by itself. This x in my second equation is by far and away the easiest one to get by itself because it's already an irregular variable. It's just not all by itself on one side. All I have to do is add 4y over to the other side to get it by itself. Okay, once I have that, now I'm doing my substitution phase. Again, I'm going to try to make it really obvious again what I'm doing. Okay, I'm taking that first equation that I haven't used yet. I'm getting rid of the x, and instead I'm plopping in 4 plus 4y. And again, once you get to this point, you've got one equation and one variable. That's all you have. Okay, so this is the same stuff you've been solving since 7th grade, right? I do some distributed property, I do some combining of like terms, and then I just work on getting y all by its lonesome. So I subtract 12. 20y equals 20, or negative 20. I get y equals negative 1. And again, just like you're going to end up doing for elimination down below, and just like you did in your previous substitution problem, and like we've done at other places throughout the year, I know what one of my variables is. All I have to do is go plug that in somewhere. Here's the slight difference here. I'm actually going to plug it in down here. Okay, so I'm actually not going to use one of my original equations. I'm going to use that modified second one. You can use any equation in there. You just got to make sure it has both an x and a y in there. Okay, so I'm going to plug it in there. X equals 4 plus 4 times -1. Okay, do the math. I get x equals 0. For both of these, before I move on to elimination, an easy way to check your answer is make sure you plug x and y into both equations. It's got to work in both equations, or you really didn't get it right. Okay, just working in one doesn't count. It's got to work in both. Okay, this one definitely does work in both. 1 and 3 does. You could check. 0 and -1 does the exact same way too. So you could check. It definitely does work out, but when we're talking exam time, that would be great if that could work out. Okay. Um, Tenny's saying we're a little low on audio. Let me double check my audio, make sure that is coming in okay. Hold on just 1 second. Hopefully that audio is coming in better now. I'll try to speak up. My voice isn't going well. If you can't hear me, I may have to redo this at a different point, but let me know when the audio seems like it's coming back. Okay. Looks like it's good on my end though. Okay. Looking at elimination. Okay. Elimination. Tenny says it's back. Thank goodness. Okay. So for elimination, our goal here is a little bit different and it's going to vary a little bit with the 3 variable one too. Okay. So for our 2 variable one, all we're trying to do is get opposite numbers on one of our variables. And it doesn't really matter which one. Okay. So in this particular case, I'm going to get opposite numbers on my x's. Okay. And I'm going to do that by multiplying the equations. I'm going to multiply the top one by 3, and I'm going to multiply the bottom one by a -2. Okay. What that's going to do is this. That's going to get me on my x's a 6 on the top, a 6x on the top equation, and a -6x on the bottom equation. Okay. The key is I got to make sure I multiply everything. So I'm multiplying all of those coefficients by 3. Okay, I'm multiplying all my coefficients by 3. Same thing in the bottom one. I'm multiplying them all by -2. I can't just pick one of them. I want to do both of them. Okay, so that's where we are. Okay, double checking my work real quick. Looks okay. All right, now the key is I have a 6x and a -6x. So what I'm going to do now is I'm going to add both of those equations together. Okay, and by doing that, I'm going to add 6 and -6 together, and those are going to add to 0. Okay, so those x terms go away. Adding 24y and -20y, I get 4y. Adding -66 and +50, I get -16. If you've done this right, one of your variables will be eliminated, and all you'll be left with is a single variable. Okay, easy enough to solve for. Just divide by 4. I've got y equals -4. Same exact thing that I did in the last one. I'm going to plug that y back into one of the original equations. It doesn't matter which one you do. I'm going to use my top one. I like that one a little better. Okay, so 2x stays plus 8 times -4. So there's me plopping in my y equals -22. And then at this point, I'm just following along with the math. Add 32 to both sides. I get 10. Divide by 2. I get x equals 5. Again, a quick double check here wouldn't hurt. Okay, but if you plug both of those numbers in, you get exactly what you're supposed to get for both equations. Now, the last one is a 3 variable system of equations. I put it in the elimination section because elimination is the process that we use here. Okay, I'm going to label these equations with some different colors because my hope is then that I can just use those colors to represent that equation, and then there won't be any confusion about where something came from. Okay, one thing I'm going to add in here right now. Regular algebra kids, you're going to have one of these on your exam, but it's going to be extra credit. Okay. Honors kids, you got one of these on your exam. It's not extra credit. Sorry, it's one of our small differences. Okay. However, so if you're in regular algebra and you don't feel like watching this part, that's entirely up to you because it's going to be an extra credit problem. I'd watch it anyway because it's not so bad, and we knew it at one point. Okay. So here's the deal. What you want to do is you want to pick two of those equations and eliminate a variable. Okay, so you're going to do the same elimination process that you just did on the last problem. I am going to use my z's, and I'm going to use the blue one and the green one. Okay, so I'm going to take my blue one and I'm going to multiply by -2. I don't want to use that x symbol. That's going to get confusing. Okay, so times -2 on my blue equation. Okay, so I get -4x plus 10y minus 2z equals -36. Okay, and then I'm going to take my green equation and I'm going to leave it alone. I don't need to do anything to that one because it's already got a positive 2z. So I'm working to eliminate my z's. That's what I'm working on. Okay. So now I'm going to add those two equations together, and we're going to see what we get. I'll use a different color for when I add them together. Let's use just regular black is fine. So we'll go -3x plus 14y equals -51. Okay, so I have created an equation that has just an x and a y. Now I have to repeat that process and do it all over again. Okay, I can't use the blue and the green one again, though. I've got to use either the blue and the red or the green and the red. I'm going to use the blue and the red. Okay, so I'm going to use my blue equation, and I'm going to multiply it this time by +5. Okay, so I'm going to get 10x minus 25y plus 5z equals 90. And my black equation, or not my black equation, sorry, my red equation, I'm going to leave alone because it's already got a -5z. Okay, so the key is I've got to eliminate that exact same variable again. Okay, but I've got to use a different set of equations. Add those together. I get 16x plus 22y equals 114. Oof, those numbers got a little nasty in a hurry. Okay. What you're basically then doing at this point is you're just doing a regular elimination problem on those two black equations. So I'm going to take that -3x one, and I'm going to write it down here. Okay, and then I've got to do a regular elimination problem. Unfortunately, there's no great way to get these to match up. So I'm going to try to eliminate my x's. I'm going to multiply that top one by 3, and I'm going to multiply that bottom one by 16. Multiplying some of those numbers by 16 is going to be a little unpleasant, but hey, this is why we got calculators, right? Okay, I'm gonna, and don't be ashamed if you're using a calculator on this. I'm gonna use a calculator to make sure I do all this stuff right. Okay, at least on a little bit of it. So I've got 48x plus 66y equals. This is one of these times where I legitimately believe using a calculator not really a big deal, right? 114 times 3. Who wants to do that in their head? 342. I kind of do a little bit. I'm running out of room, so I'm actually going to move this back up to the top if you guys don't mind, okay? So I've got 48x plus 66y equals 342. The bottom one I'm multiplying by 16, so I've got -48x, okay? Don't be ashamed if you're doing 16 times 14, on a calculator. That's not really a big deal. I'm doing it just to double check. 224. And then 16 times 51, that's 816. We got to make sure to include the negative there, though. All right, now we're going to add these together, okay? So we get for this one 290y. Yikes, that's a pretty big number. And then 816 or negative 816, excuse me, and positive 342 combined to 474, negative 474. That's not great. That means I screwed up somewhere. That's unfortunate. Okay. I'm going to follow. Oh, Sophia may have corrected me. Yep, Sophia's right. It's a negative 22y. Thank you, Sophia, for saving me in the chat window. Good work. Bonus points to you. Okay, so with that being negative 22y, that means up here, that should have been negative 66y. Okay, I got to fix this over here. So now I've got 224, positive 224, and negative 66 for 158. That I think is going to work out a lot better. Okay, because now we're going to do 474 divided by 158. And we get 3. Thanks to Sophia Lou for saving the day. See, even your teachers make mistakes. That was probably going to take me a while to figure out too. Okay, and that's a negative 4. That's a negative 474, even though my negative sign doesn't look great. So I got y equals negative 3. Okay. All you're doing now, that is by far and away the hard part of the problem. The bulk of it's over. All you got to do is go back and start plugging things in, okay? So you're going to take one of those two black equations. I'm going to use that negative 3x one. And unfortunately, I'm going to have to erase some stuff here. Okay, so I've got a negative 3x plus 14y I'm going to use after I clear some of this stuff out. There we go. Okay, make that a little bigger. There we go. Working on a tablet here, friends. Kind of ran out of room. Okay. So we had negative 3x plus 14y equals, I'm going to go back and look. Negative 3x plus 14y equals negative 51. And all we're going to do is plug in, oops, it's negative 51. All we're going to do is plug in negative 3. And we're going to solve. So 14 times negative 3 is 1428. That's 42. Add the 42. We get negative 3x equals negative 9. And we get x equals 3. Okay. That gives us 2 of our variables. Now we can just go back to one of those original problems. Okay, so I'm going to go back to, I like my middle green one there. That looks pretty nice. Okay, so I'm going to substitute. I've got x plus 4y plus 2z equals negative 15. And then I'm going to plug in x and y, so I know x is 3. I know y is negative 3. I've got 3 plus negative 12 plus 2z equals negative 15. Combine like terms, I get negative 9 plus 2z equals negative 15. I'm going to add 9 to both sides. I get 2z equals negative 6. Divide by 2. Z equals negative 3. Oof, that was an ordeal. Okay, and honestly, these problems are pretty long, and what you kind of notice is, and it was an unfortunate thing that I made a mistake while doing this live, but what you notice is even a simple thing like a negative sign can really, really screw things up in a hurry, okay? So, you know, do the best you can on these, and, you know, again, it's a simple process when you boil it down to, I'm eliminating the same variable twice. And then I am eliminating from those two equations, doing a regular elimination problem, and then kind of working my way back. Okay. I know the audio was apparently cutting in and out a little bit on this one. Part of that might be, I mean, my internet's not working great. Part of that might be my weird voice today. So if there's anything in here that didn't quite sound right or you couldn't quite figure out what's going on, let me know. And if you're watching this later, definitely come talk to me if there's any issues that come up. But for the rest of you, I hope this helped. And we'll have another one of these coming up on Thursday. See you then.